So good afternoon, everyone. Oh, well, in this case, good night. My name is Enrique Bludau, and I will show you my record. In this case, let's start. A CPU, also called Central Processing Unit, is one of the most important components in many devices. Its its main function is to process data, perform calculations, and coordinate the operation of the system according to the instructions of the program. In most of the cases, this is the most important component in this for example computers, laptops. This is like the brain. Okay. The RAM, or also called random access memory, is a type of volatile memory that temporarily stores the data and programs that the CPU needs to run quickly. We can imagine the RAM as a group of boxes. Okay, and a hard drive, also called a HDD, is a storage device used to permanently store data on a computer or other electronic devices. Well, in this case, a hard drive is not the more common thing to use in these days. Is more cheaper, but at the same time is very slow comparing to the SSD, because the SSD is more faster, because the hard drive works with magnetic disk. Okay, what are comments? Is like a space in our code that will not be executed. The main purpose of the comments is to improve and help the programs to understand the code. Comments like this, this is not very difficult to understand. What a variable is. It is a space in the computer's memory that stores a value during the execution of the program. The this concept has to be with RAM. For example, if we create an integer value, this value will be saved in a space of our RAM. Okay, and what is the difference between integer and floating point calculations in C++? We have a lot of difference. I will say you the three more importance, I think. First one, integer processes are mostly more faster than floating because the values are more simple, like 2 plus 2, 3 plus 3. But in floating number we have decimals that complex the calculation. Also, in floating calculations we use more memory or bits for the same reason, because the floating calculations are more complex with numbers more biggest. Not mathematically talking. We have more numbers. The integer numbers plus the decimal numbers. And in floating calculations, we can get a more exact result, because in integer the result is truncated. For example, if we do an integer calculation, for example, 5 divided by 2, in an integer calculation, we will get 2, but this is not exactly correct. But if the calculation is floating, we can get the exact number, which is 2.5. Now, I wanted to explain you my program that I did. In this case, to solve this problem. The problem was originally for Project Euler, but in this case I changed something, because in Project Euler was only they project elder only want the last number, the last prime factor, but I wanted to output all the prime factors of the number, not only the last one. I think it is more interesting. Okay, so let's start with my code. This is my main block. I have four variables. The first two are for the two different for I have in the program that I will show you in the process of that I explain you. And this value is, well, as you can see in the number, is the input value that the user will put, and this last value I will use it in my second for. So okay, those four lines are only to guide the user in the process that he or she use the program. Here I read the input value, and this while is like a validation. What it means, if I only put CIN here, it means that the last value that the program read, I mean the last input that the program read, if this is not the same like as the type of variable we put, then it will return false. For example, if my input type of variable is int, but the user put a string value, for example, if the input here is a word like hello, but input value is a integer value, so in this case the while will be false, and in the output we can say only have a good day. Why have a good day? Because this validation is like as you can see here, type whatever you want except a number if you want to exit. Okay, so let's continue. This first validation is if the input value is less than 0, I mean negative numbers, then I need to change it to the absolute value of the number. So only multiplies by less 1. Those other two conditions is if the input value is 1 or 0. This is to make the program more easy, because the only prime factor of 1 and 0 are the same numbers. I will explain what this is in the second for. This is also to guide the user. Okay, and this is the more important thing in the program. We have a for to get all the prime factors. The for starts with the number 2. Why number 2? Because here I already evaluate if is equal to 1, and this is the condition. I didn't know that. For example, let's say we have the number 835, and I want to know the largest prime factor. Let me get the calculator. The square root of this number in this case is 28.089, but it doesn't matter, is equal to 28. So what it means? It means that the largest value cannot be more than 28. And this is very important to put the condition of the for. And increment the value of I only by 1. I mean, to evaluate all the possible prime factors. I mean, the first evaluation will be if the number is, if one of the prime numbers of the number of the input value is 2. If the input value divided by 1, the residue is equal to 0, then it means that it means that 2 is a prime factor. Then output the number 2 because it is a prime factor, and divided the number all the times that can be possible by, in this case, the first number, which is 2. Divide the input value until the value is no longer divisible by that factor, and it's the same process. I mean, this is a for. I mean, it's a iteration. The next possible prime factor is 3. The same process, then 4, then 5, then 6, and this is how I get all the possible prime factors. I will explain this later, because next is this. If the input value is greater than 1, then it means that that input value is the last one and at the same time the largest. Then I need to put it. The program works. If I delete this code, it will still work. So what is the point of all these with all this part of code? If I put a very big number, in some of the cases the large value will be, for example, 4003, but this is not the correct largest number, because in this case 4003 have more prime factors, like 56 if I remember good. So just in these cases that the number is too big, I need to put a second form just to confirm. If the input value, I mean the last number I get in the first form is greater than the square root of the original number, for example, the residue is the input value, then I need to do the same process as here, as much times as the last input value is less than the square root. This is only to confirm that the large number of a very big number is correct, but in most of the cases I will not need this part of the code. And these 3 lines are only to guide the user, and here I get another time the input value to repeat the while process as much times as the user only put numbers. Now I want to show you an example. This is how it looks. I mean, looks nice for me. So let's start with a simple number, 15. As you can see, 3 and 5, this is a correct value. Also, for example, a prime number, 11 is 11. 12, 2 and 3. And now let's try the big number. I don't want to write all of this, so it will only copy and paste. If you want, you can try to make sure that those 4 numbers are prime values. The true is yes it is, and according to Project Euler, the last number is 6857, and this is in the case of a big number. So let's try, for example, other big number. So yes, this is how the program works. So that's all for my part. Thank you.